at origin on the IKAWA by Mr. Matthew Orchard, who's a specialty coffee professional, plot roasting. So Mr. Matthews started his specialty coffee back in 2009 when he founded a coffee house business on the south coast of the UK. Since then, he has gone on to work with and consult for a variety of coffee shops and roastery businesses across London and the southeast. Matthew founded Plot Roasting in London in 2019, a specialty roasting business which focuses on building long-term purchasing relationships with innovative producers around the world. Matthew is a certified Q grader and an SCA authorized trainer in sensory skills, green coffee, roasting, and brewing. Over to Mr. Matthew. Thank you.
Thank you very much. Cool. Wow. Thank you for such a wonderful introduction. Just a quick word about Plot specifically is that we kind of founded Plot in 2019 with a clear mission to kind of further coffee education in the south of England. So we have a training school there where we teach the things that we're really passionate about. So roasting, green coffee, sensory and brewing skills as well. So these are the things that we kind of specialize in and are really interested in. And today we're going to talk about sample roasting, which is one of my favorite subjects. And we're going to do a little bit of a presentation first, and I'm going to talk to you a little bit about some of the theory behind kind of roasting theory, how the IKAWAs actually work and how to get the best out of them. And then we're going to do some practical roasting. So any of those of you who are interested in kind of doing some practical work, we've got some roasting to do with some different species from India. And then we can cup them to see how we can explore the kind of range of flavor potential that we can get from these coffees, basically. So sample roasting. How many of you have done any sample roasting before? Can I see any hands? Anyone? Yeah? A couple of people? How many of you are roasters already? No? One over there, yeah? A couple? How many of you are coffee growers? Yeah? Fantastic, a good amount. And as coffee growers, do you taste your own coffee? If you do, yeah? So you have the opportunity to taste it. Do you roast it yourselves? Or, yeah? A little bit. Well, hopefully, I think that's a very, very valuable, really valuable thing. And hopefully today you might learn a few things about how to kind of get the best out of your coffee. So really, within the value chain, there are three main people who are doing sample roasting. So this is part of our daily routine as a roasting company. But we have coffee buyers. So their main interest is in basically understanding the value of coffee and identifying defects and assessing the quality potential of a lot of coffee. So for coffee growers, it's also really, really important because you can understand the quality of your product and understand where it sits in the market. But also if you're making changes to processing or different agricultural practices, you can learn how they relate to the end cup profile, basically. And then as a roaster, we roast slightly differently because we want to really explore the potential of a coffee and understand when we come to do production roasts, we learn the flavor potential and understand, create targets basically for us to create better production roasts. But we also use it on a daily basis for QC and QA because if we've got coffee that's sitting around for a while, we're buying large lots and using them up over time. We want to understand how they're changing as they age, basically. So for sample roasting for quality assessment, the SCA created a protocol. And the reason why this is kind of important is because obviously, when you're buying coffee and assessing coffee, we want to be tasting it in exactly the same way, or wherever we are in the world. So having a roasting protocol is super important. Now, this roasting protocol has been used for the last 50 years or so, and It could probably do with a little bit of updating, to be honest. So in our daily sample roasting routine, we kind of take this as a baseline, and we have some of our own kind of targets that are more achievable and more applicable to our business. So we should be roasting within 24 hours of cupping, and ideally allowing it to rest for at least 8 hours. Well, unfortunately today we don't have the time to allow these samples to rest, so we're going to be tasting them straight after the roast. The roast level is also really, really important. So has anyone heard of Agtron Gourmet before? It's like a way of kind of analyzing color and assigning it a numerical value, so 0 being completely black, up into the hundreds, which is very, very light roasted coffee. So this target of Agtron Gourmet 63 represents the ground average color of the coffee that's been roasted. Now, this as a target is it's a little bit tricky because this might be quite dark for some people. It might also be quite light for some people. So depending on your own preferences and your business and your customer base, you may have a very different kind of color target. This next section as well, the roast should be completed in no less than 8 minutes and no more than 12. This is a really, really big window for a roast. So this can make a lot of sensory difference, and it really depends on what kind of roaster you're using as to whether you're going to be able to complete a roast in 8 to 12 minutes. The power to batch size is very, very important and absolutely key here. So particularly today with the IKAWA roasters, a roast of 12 minutes would be way too long. They're a very, very powerful roaster. A lot of hot air, the hot air to bean ratio is huge. The power of the burner is incredibly strong. So for an IKAWA roast, you'd be expecting kind of anywhere between 5 and 8 minutes. And the samples should be immediately cooled, no water quenching. So color as a target is absolutely important. So there's some very, very interesting research done by a company called Coffee Mind, who are based in Copenhagen. And that's led by Morten Munchow, who is one of the major contributors to the SCA's roasting module. And they found through experiments and a lot of scientific sensory analysis that color was the most strongest indicator of coffee flavor. So what they did was they roasted the same coffee using very different profiles, but all with the exact same color target. And they found that most of the people couldn't tell these coffees apart in triangulations. It was only really when the coffees had a wide difference in color that people could actually tell them apart. So they kind of summarized that color is the most important predictor of coffee flavor. So we always choose a color target for our sample roasting, which suits our own market and our preferences. So we can roast the coffees and see how they express themselves in a color target that's going to be suitable for our customers, basically. So second to color, we have development time. So just for anyone who hasn't done any roasting before, it's a very, very complex, loads of complex chemical reactions are going on. Coffee's turning brown, and as we're applying heat to coffee, it gets to the point where the cellular, cell-like structure of the coffee, so much pressure builds up inside from the heating moisture and the chemical reactions that are going on that we get to a point called first crack. And this is a kind of key indicator that the chemical reactions have kind of started to reach a certain speed. So we know that from this point of first crack, Everything after it we refer to as development time, and this is absolutely key in shaping the sensory profile of the coffee. So when we can play with different development times, what we're doing is we're modulating changes in the balance of the sensory profile. So a very, very short development time would create more aggressive acidity. And if we have a very, very long, slow development time, then the coffee can taste baked and quite flat and really boring, basically. So we can modulate the balance of acidity, bitterness, and sweetness. Those three things we're really kind of playing with by changing the development time. So that's the second thing that's key. The third thing is the actual overall speed of the roast. So we're referring to this as the amount of time until we reach first crack. So as you can see here, we've got two different profiles that both achieve the same average ground color, which is quite amazing. So you can roast for 3.5 minutes or for 6.5 minutes and still reach the same color. But the difference here is that the speed of the roast affects the variation of color across the bean. So if you imagine when you're roasting coffee, it takes time for the heat to actually disperse through the coffee bean and into the center. So as a result, if you roast much shorter and faster and you're heating it with a lot of heat, it's going to be more cooked on the outside than it is on the inside. So we've got a wider delta. If we're roasting a little slower, this is more conducive to much more even development. So the heat's allowed to diffuse to the center. It has longer to actually get through the coffee and cook it more evenly. So we end up with more even color from the inside to the outside. So this will also give us a slight difference in the balance of flavor profile. So the larger the delta, the faster the roast, we're going to see, or we're likely to see, more aggressive acidity and possibly some kind of roast notes as well, so that kind of charcoal burnt notes. And the other thing that's going to affect how coffee actually behaves inside a roaster is its physical attributes. So this is something that I'm particularly fascinated in. So if we roast all of these coffees on exactly the same profile, they're going to come out at very different colors. And the reason for that is some of the actual physical attributes of the coffee itself. So all of these things play a part. The species, different species have different sizes, different shapes. The varieties as well, some varieties of coffee like Maragoripe are absolutely huge, where others like Mocha are tiny. The process actually plays a big difference, whether the coffee is washed or natural. Screen size, very, very small beans, very, very large beans will develop very, very differently in the roaster. Likewise, the density of the coffee itself. So the denser the material, actually the easier it is for heat to penetrate into the middle of the coffee. So the less dense, it doesn't tend to turn brown as quickly, basically. So we have to have a slightly different approach for less dense coffees. Likewise, the amount of moisture that's in the coffee, moisture will act as a very good conductor of heat. So higher moisture content coffees will allow the heat to actually penetrate the bean very effectively. And finally, water activity, which is a measure of how well bonded the water is to the cellular structure of the green coffee, or how easily it will give up its moisture. And there's several studies that have linked Maillard reactions, or the speed and amount of Maillard reactions, to water activity. So Maillard reactions is one of the most complex chemical reactions that's happening during roast. And it's the thing that's kind of responsible for a lot of the aroma and taste of coffee. So the roaster that we're going to be using today is the IKAWA. So this is it's very specifically a sample roaster. So it will only roast 50 grams at a time. The things that I like about it, or why we use an IKAWA, are firstly, they're very, very portable. Secondly, they're very, very programmable. And because of that, it means we can basically set a profile, and then, as a roaster, we're always running around doing lots and lots of different things in the roastery. We can set a profile, roast some coffee, and kind of walk away. So in the past, roasting for sample roasting was always done on small barrel roasters, which requires a lot of attention, and it's not quite as easy to get good consistency. But with an IKAWA, if we set up a decent profile, we can get very consistent roasts time and time again. So what we can see here is the way the IKAWA is built. It has a roasting chamber in this central part. And you can just see in the image, there's a temperature probe. If you can't see that, we can come and have a look at the actual physical roasters we've got. So this temperature probe is what we're going to be using to kind of base our profiles on. And if we have a look over here and the app that comes with it, we've got three separate lines there. So this line at the bottom, you can see coming down and then up again, is for airflow. So this roaster is a fluidized bed roaster, and I'll talk a little bit more about that in a moment. But airflow is key in basically controlling the roast. We have the red line, which is the exhaust temperature. So this is coming from the exhaust probe that you can just see in the top of the roasting chamber. And then we have this yellow line at the top, which is the inlet temperature. Now, the inlet temperature is actually the heat that's being applied to the coffee. So this is a very good indicator of how much energy we're actually applying to it. And you can see it's very, very bumpy. And the reason for that is if we program this exhaust line and tell the roaster that's what we want it to do, it has a PID control, so the computer will basically be making small adjustments to the inlet temperature in order to achieve this red curve. So let's kind of break this down into the separate areas. So first of all, the exhaust temp. So the exhaust temp is actually a very, very good indicator of our bean temperature. So if anyone's done any roasting on a normal drum roaster, you know that your bean probe is absolutely key to understanding how your coffee is developing and how your roast is changing. So because we don't have a probe directly into the actual bean mass, we're measuring the air that's coming out of so the exhaust air. So normally in a drum roaster, this would be very, very much hotter than the bean temperature. But because of the way this particular roaster works, the air is it's applied from underneath the coffee, so it's applied to the whole mass of the green coffee that's roasting. This means that some of the heat energy is absorbed, and the exhausts will always be just slightly lower by a few degrees than the actual temperature of the coffee that's being roasted. So this is from a roasting consultant called Rob Hoos, who voided his warranty on his very expensive roaster by adding a bean probe so that he could measure this and test it. So yeah, there's very, very efficient conductive heat transfer, which is why the exhaust temperature is slightly lower, but it's a very good indication of where our roast is going. So as I said, this is a fluidized bed roaster. And the reason that's important is because it's very different from a normal drum roaster. So fluidized bed roasting basically is characterized by the coffee isn't moved by a drum or by paddles or a mechanical kind of means. It's moved literally by the air, the velocity of the air. So it's really important that we get the airflow correct. So the airflow is doing a few things, as well as applying the hot air to the coffee. It's also removing smoke and chaff from the roasting environment. And it controls the speed of the movement of the coffee. So now, because coffee is changing in the roaster from when it's green to when it's roasted, it's losing density, so it's becoming much larger. It grows. It loses a lot of moisture, so it loses weight. And because of this loss of weight and density, it becomes much lighter and it moves around a lot quicker. So if we have airflow that's way too high, then what happens is a lot of coffee just shoots out of the roasting chamber and we end up with a smaller amount of roasted coffee. If our airflow is way too low, then you can see the PID really struggles to maintain the curve that we've set, and we end up with very, very bumpy, wavy lines, which is a very uneven heat that's being applied to the coffee, so it's not really very good. We'll get very, very inconsistent results. So it's important to start with a decent amount of airflow and then lower as we go towards the end so we can keep the coffee inside the roasting chamber. So what we tend to profile, which is kind of slightly more advanced, is once you have an exhaust profile set, we then move on to programming an inlet profile. So there's two options. Exhaust profile is obviously, it's easier to predict where the coffee is going to go than starting with an inlet profile. So we roast using exhaust first. And then once we've got a profile that we like for a particular coffee, it's very easy then from the app to convert that and create a inlet profile. So you're really controlling the application of the heat to the coffee. So you can see the difference here between the two. We have the exhaust profile here on the left. The inlet is being controlled by the PID, and as a result, you get this very bumpy kind of profile. However, with the inlet temperature, if we're programming that instead, we get a really, really nice smooth curve. It doesn't seem to be as temperamental when we're in different kind of environmental conditions either. So it really means you can very accurately apply the same amount of energy to your coffee every time. So this is something that's very, very particular to the IKAWA, and it's if you're an IKAWA user, then I'd recommend playing with this. It's really, really good fun. And then just a little word on it's a little bit of an advert for IKAWA, but they have a new feature in their newest roasters, which I'm particularly excited about. So we've just got one of these back in the UK, and basically they have developed a way of automatically detecting where first crack happens by measuring the moisture release across the roast. So whilst this is quite a cool feature to have, and anyone who kind of roasts on IKAWA knows how difficult and subjective it is to actually decide when first crack is starting. So that's pretty cool, but also the fact that we can then start to relate this data to some of the green coffee's physical properties is the thing that I find incredibly exciting, and I think once we've got some more data kind of recorded from lots and lots of different coffees, we are starting already to see some kind of trends. So this allows us an invaluable window into understanding how certain green coffees are going to behave in our roaster. So what I'd really like to do now is get some people up to do some actual practical roasting. So we've got 3 IKAWAs here. We've got 3 different species of coffee, all from India. So we've got a Robusta, we have an Arabica, and we have an Excelsa. And we're going to roast each one to 3 different profiles. Now, these profiles are just taken from IKAWA's kind of suggested starting point, and then we've made one much shorter, and we've made one much longer. And what I'd like to do is roast each coffee to all 3 of these profiles, and then we can all kind of taste them and cup them afterwards, and just see kind of start to explore the breadth of possibility, basically, from using different sample roasts. So For each coffee, there is no one kind of one-size-fits-all profile. Every single coffee, needs to be kind of tweaked and changed a little bit. So yeah, who'd like to come up and do some roasting with us? Yeah, can we have at least 3 volunteers? That'd be great. Okay, I'm going to switch the mic off now, but if anybody wants to, if anyone has more questions or anything like that, or wants to just come and watch the roasting going on, that'd be really cool, and yeah, I'll field any questions, and then we can talk through the coupling as well. Sorry, could I pop this off? Basically, just temperature rise. So temperature, time, and also the airflow. Take the actually control panel, the velocity of the. Yeah. 100% meaning airflow. So if you have like full airflow, it tends to be a little bit too, tends to be a bit too much. So we start around 80%. So it's really good. Yeah, somewhere between 80 and 60.
Little bit.
Yeah, it's going to be that. We've got roast one in here. Well, it depends on your own method. So let's see. This one will be much lighter. So we're going to have three very different roasts. Okay, so we sent this short profile now to this roaster. You guys, do you need a sample? Yeah?
What's the difference between fluid bed?
It's actually so we can't really like take these profiles and then scale them up, but what we can do is explore like the differences in color and find a color target that we like to do, and that's what we use to start focusing on profile. Right, cool. So that's yes, so I put this Thanks for the assistance. So, how's this one doing? Is it nearly there yet? Yeah. Yeah, so we could play with development here. The problem with the IKAWA is like actually pinpointing where the first crack starts. So really you have to choose like a temperature to say this is what the first crack is going to be, and then you can start to play with the times. Absolutely, I mean flavors are kind of developing from the run of the way on reaction slowly with caramelization. Absolutely, yeah. So, but the thing is, after first crack, what you've got is the increase in solubility because of the actual force of the crack is opening up lots of those cracks in the structure. So when you grind this, you can't use the solvent like water, you can extract more. But also, the chemical reactions are happening really, really fast. So the speed of the roast, the intensity of all of those chemical reactions are very quickly. So this is the point where it's very critical. So controlling that development phase is really important to get better tolerance, right? Between natural and like what? And honey. Okay. So for honey coffees, I prefer to roast more similarly to a washed coffee actually. I like a little bit more flavor. But yeah, absolutely. I quite like naturals personally to be like really light and fruity and interesting. Cool. But, you know, we all have different tastes as well, so that's what's so interesting and exciting about roasting is there's no right or wrong.
This is the total roast for 5 minutes 45 minutes. So now it's cooling down.
So we can see already from the outside, it's a bit light. This will be much lighter on the inside as well, so we'll have a different brown colour score. And you can see it's a bit more uneven as well.
It will be like
Yeah, exactly, yeah, it's a faster, much more even.
Once the cooling down is done.
Right, next.
Yeah, once the roast is
So, well, the next one's going to be darker. Yeah. So you'll see, like this, because of the beans tend to look a lot darker in a IKAWA than they would on a drum roaster anyway. The outside tends to get more special and faster roast like this. So you'll see when it's ground, it should still be fairly light. It depends on how you want to present it, you know. Where's it going? So, it's all good. It's all done.
this one is here.
So I just had 3.
The first one.
I don't know what that was. That one might have been on the roast already. Long short.
Hello. Can you take me a picture?
Did you? I think someone might have.
Sorry, bro.
It doesn't matter because we've already done. We only need to do one anyway.
Actually, the charge is same for all creating multiple.
So I'd rather use the ones that we've had anyway, just because we're going to start to see like differences it makes across different species. So just so it's a fair comparison, but it would be quite easy to do. If there's any time after, you're welcome to go crazy with it and try it. I can show you the
वो मोबाइल ತೆಗೀರಿ
Yeah, they're all naturals. I couldn't get hold of any washed Excel, so we wanted to just get back there.
Excuse me.
Yeah, this one is solder one. This is
It'll be lighter on the inside as well. Yes, it's had a I think that really depends on your own preferences, but I would, so in an IKAWA or in a drum roaster? In general, in a drum roaster, I like to explore anywhere between 45 seconds and 2 minutes. So, you know, it's a real scope to shape. Absolutely, yeah, sorry, 1 second. Oh, did you say Right, ready for the third roast? So which one is it? This one must be the shorter. So we can already see that we have Yeah, I can show you. Yeah, I mean they've got pressure. Boiling temperature of water is lower. So generally there's higher altitude. So most roasting first and everything is just roasting synchronized. So we had to really play it. So yeah, it's a big difference.
Medium pressure.
Yeah, oh, absolutely, yeah. If you're where you want to be, just press this button and go straight on. Also, running on that color, those good roasters should be safely related to the fan, but if you do want to, as whilst it's roasting, you can change, yeah, you can look at it as a table. It's a lot easier.
Exactly. So one common tactic that other people use is they use it much longer than they want it to. And then stop it.
Just a part of understanding the technical profile you have.
Yeah, and that's kind of more energy will take also density very well as well. The more pressure basically. This is really just an exercise to show you. So like relatively small.
That you have too many.
So the short one, yeah, of course. So it's all about managing the amount of conduction. So imagine if your drum is moving quite slowly, then the coffee spends longer touching the sides of the drum. If it's moving very quickly, it's tossing the coffee around more, so it spends more time in the air, basically. So you're trying to limit the amount of conduction. So the thing that I would recommend is starting with as high drum speed as you can get, without it causing centrifuge, because if you go too high, it's just going to stick to the drum, right? So if you have a very, very fast drum speed, it causes the centrifuge in the coffee, which is the deep sides. So you want to go high enough to keep it moving, but without causing a centrifuge. I mean, it depends on your roaster and the size of the drum. I don't think there's any kind of like... I would just experiment, try going as high as you can, see what happens, and then start bringing it down slightly. But yeah, you're just trying to limit the amount of conduction basically and stop the coffee from spending so long touching the drum. I mean, yeah, I mean, really, those ones it could end up being a fire risk as well at some point. So I would recommend having your drum cleaned like once every few years. But you should really avoid roast the surface on a yearly basis, depending on how much but yeah, it would be good to reduce the amount of oil that's in the coffee. I would definitely. Were you able to access it yourself? Because it's very easy to clean. You just kind of brush it out. Do you actually have to take the roaster apart to get it out?
So it's physically, that's kind of what it's happening. However, you might see different readings from your temperature probe on your machine because it depends on the design of the probe itself. Some probes are much faster and more responsive than others, so the thickness of the probe will be based. So you can see a range from like 100 layers to it will be really depending on the design of the machine itself. But I tend to be more so now I tend to use for consistency's sake, choosing particular temperature as a marker for the first rack. One particular profile, temperature, because judging by the sound is very different roasters are going to be slightly different. So we just use temperature as a marker on one profile and say that's very So there's some stuff happening with crack, like that crash is usually too much energy getting onto this crack. So you need to make a larger reduction before first crack, basically. And it's the same thing, so allowing the energy that's coming through the bottom to carry the roast crack. That's my go-to strategy.
Long time no see.
Need to give us a video explanation. Yeah, I used to do that as well. Yeah, so making a slightly larger adjustment. I can teach you a bit more about the roasting for this if you like. So it's a great way. So we're only supposed to have another 10 minutes. So what I'll do is we'll get this set up with cupping, and then whilst the cupping's being prepared, get this right with it. So if you want to start doing that now, did you want to create it? No, there's no right or wrong. It's sorry, I used so I'm here until the 3rd, I think, 2nd or 3rd. Yeah, absolutely. I mean, I'm going to be hanging around for a while today as well, so we can chat more, so it'll be really interesting. Cool. Did you wanted to create a profile? Yeah? So what kind of, do you want to create an inlet profile or? Yeah, so if you had like a particular profile that you liked, your own brand new one. So what we have to do to create one, we have to kind of start with one that's already in there. So if we go into, we could choose from a roast that's been done, or we could choose from a sample library. Yep, so, okay, well I'll tell you what, let's go into this and set it. So from here, you can touch each point. You can add extra ones. You can just go down, or you can look at it.
Which end temperature only we can set?
Yeah. So the exhaust temperature. So we can change the temperatures and the times here, or you can do it in visually here. So it's here. It's enough for the cuppings, but you know, I'm very excited for you to design another profile. I'm going to go and get these ready for cuppings. So yeah, have a little play, and then you can save it and send it. Okay, so this is the Robusta. So we've got in this order 1, 2, 3.
You can leave the packet open and keep going.
Perfect. That's in there. Is this the right order as well? That looks like the Longbos.